In part 1 of our series, experts debunked recent headlines suggesting that the Yellowstone supervolcano was on the verge of a catastrophic eruption. The key takeaway was that the amount of molten material is not sufficient to trigger the kind of large eruption Yellowstone is famous for. However, Mount St. Helens is currently erupting, and if that wasn't enough to make people nervous, it has triggered an alert at Yellowstone National Park. Could this be the one-two punch that leads to a supervolcanic eruption? Are we about to be covered in ash up to our knees? Mount St. Helens, located in Washington state, is one of the most well-known volcanoes in the United States. This active stratovolcano has a history of erupting, with its most famous eruption occurring on May 18, 1980. That event is etched into the memories of many as one of the most catastrophic volcanic events in U.S. history. Before the 1980 eruption, Mount St. Helens was often called the Mount Fuji of America due to its symmetrical cone shape. However, the 1980 eruption drastically changed its appearance. The eruption was triggered by a magnitude 5.1 earthquake, causing the entire north flank of the volcano to slide away in a massive landslide, the largest in recorded history. This led to a lateral blast that flattened everything within a 230 square mile area. The eruption sent a plume of ash 15 miles into the atmosphere, affecting several states and causing extensive damage. The impact was devastating, 57 people lost their lives, and thousands of animals perished. The landscape was transformed, with Spirit Lake completely altered and entire forests wiped out. The eruption caused over $1 billion in damage and left an indelible mark on the region's environment and economy. Fast forward to the recent eruption that has everyone talking. On what seemed like an ordinary day, Mount St. Helens reminded us of its formidable power. The eruption occurred in July 2023, catching many by surprise. Despite ongoing monitoring leading up to the event, signs of increasing volcanic activity had been detected. Scientists noted an uptick in seismic activity, with numerous small earthquakes shaking the region. There were also changes in gas emissions and ground deformation, classic indicators that magma was moving beneath the surface. However, the exact timing of volcanic eruptions is notoriously hard to predict, and this eruption still caught many off guard. When the eruption finally occurred, it was both spectacular and terrifying. A towering column of ash and gas shot up from the volcano, reaching several miles into the sky. The explosion sound was heard from miles around, and the sky darkened as ash began to fall over the surrounding area. The immediate impacts were felt most acutely by the communities closest to the volcano. Ash blanketed towns and cities, making breathing difficult and reducing visibility. Roads became slick and dangerous, leading to numerous accidents. The ash also posed a significant hazard to aviation, with several flights cancelled or rerouted to avoid the ash cloud. The eruption caused power outages and disrupted communication networks, adding to the chaos. In the wake of the eruption, local and state authorities sprang into action. Emergency measures were quickly implemented to protect the public and manage the crisis. Evacuations were ordered for the areas most at risk, with thousands of residents being urged to leave their homes and seek safety in designated shelters. Authorities implemented strict safety protocols to minimize the ash's impact, including distributing masks to help residents breathe more easily and advising people to stay indoors as much as possible. Schools and businesses were closed, and transportation services were temporarily halted in the most affected areas. Scientists and experts played a crucial role in guiding the response efforts. Volcanologists from the United States Geological Survey, USGS, and other institutions provided continuous updates on the situation. They analyzed data from monitoring stations around the volcano, using seismic readings, gas emissions, and satellite imagery to track the eruption's progress. One of the key messages from scientists was the importance of staying informed and prepared. They emphasized that while the immediate danger from the eruption might subside, the volcano could remain active for an extended period. Residents were advised to remain vigilant and follow the guidance of local authorities. The Pacific Ring of Fire is an area in the basin of the Pacific Ocean where a large number of earthquakes and volcanic eruptions occur. This region is shaped like a horseshoe and includes the coasts of South America, North America, East Asia, and the islands of the Western Pacific. It's called the Ring of Fire because it's home to about 75% of the world's active and dormant volcanoes. But why is this area so active? It's all about plate tectonics. The Earth's outer shell, or lithosphere, is broken into several large and small tectonic plates. These plates are constantly moving, and where they meet, you often get intense geological activity, like earthquakes and volcanic eruptions. The Ring of Fire is essentially a line of these tectonic plate boundaries, making it a hotspot for seismic activity. Mount St. Helens is part of this dynamic region. Located in the Cascade Range, it is one of the many volcanoes in the Pacific Northwest that owe their existence to the subduction of the Juan de Fuca plate beneath the North American plate. This subduction zone is a place where one tectonic plate is being pushed under another, melting into magma that feeds the region's volcanoes. Now, let's talk about Yellowstone. Yellowstone isn't just a national park known for its geysers and wildlife, it's also home to one of the largest active volcanic systems in the world, often referred to as the Yellowstone supervolcano. This supervolcano sits over a hotspot where hot molten rock from deep within the Earth rises up to the surface. While the 1980 eruption of Mount St. Helens is the most well-known, the volcano has a long history of volcanic activity. In 1479 and 1482, there were big eruptions that created large pyroclastic flows and lava domes. Several smaller eruptions in the 1800s reminded people in the area of the volcano's potential danger. Each of these events helped scientists learn more about how volcanoes behave and why it's important to keep an eye on them and be ready for any possible activity. On the other hand, Yellowstone is renowned for its supervolcano. 3 huge eruptions from this volcanic system have occurred in the last 2.1 million years, each one changing the climate of the area and the world. The Huckleberry Ridge eruption, 2.1 million years ago, was the biggest, throwing out 2,450 cubic kilometers of volcanic material and forming the Huckleberry Ridge Tuff and a huge caldera. The second eruption, Mesa Falls, 1.3 million years ago, was smaller but still significant, as it formed the Henry's Fork caldera and released 280 cubic kilometers of material. The most recent eruption, Lava Creek, 640,000 years ago, created the Yellowstone caldera we see today, with 1,000 cubic kilometers of ash and lava. These eruptions were so powerful that they caused volcanic winters, where global temperatures dropped significantly. Yellowstone is home to one of the largest geothermal areas in the world, with famous geysers, hot springs, fumaroles, and mud pots. Millions of people visit Old Faithful every year, making it one of the world's most famous geysers, showcasing the area's ongoing geothermal activity. Even though there haven't been any recent eruptions, Yellowstone is still active. Scientists are closely monitoring the frequent earthquakes and ground deformation to assess the likelihood of a future eruption. When Mount St. Helens erupted in 1980, people reacted swiftly and profoundly. Geologists had warned of increased volcanic activity in the weeks leading up to the eruption, but despite evacuation orders, some individuals chose not to leave, resulting in tragic loss of life. The disaster garnered significant media attention, raising public awareness about the dangers of volcanoes. This awareness spurred improvements in volcanic monitoring and emergency response plans. After the eruption, significant investments were made in studying volcanoes and enhancing early warning systems. In 1982, the Mount St. Helens National Volcanic Monument was established, which protected the area for research and education purposes. Today, Yellowstone remains an active volcanic site, but it is closely monitored by the Yellowstone Volcano Observatory, YVO, part of the U.S. Geological Survey, USGS. YVO scientists use a variety of tools to track volcanic activity, including seismic sensors to detect earthquakes, GPS to monitor ground deformation, and gas sensors to measure volcanic gases. While there are no signs of an imminent eruption, the continuous geothermal activity at Yellowstone, such as geysers, hot springs, and fumaroles, indicates that magma is still churning beneath the surface. Understanding the connection between Mount St. Helens and Yellowstone requires exploring how volcanic systems can influence one another. Volcanic eruptions are often part of a larger pattern of geological activity. One way eruptions are connected is through seismic waves, which can travel through the Earth and disturb other volcanic systems, potentially triggering activity. This phenomenon, known as volcanic triggering or unrest, highlights the interconnection of volcanic systems. Magma movement is another link between volcanic systems. The Earth's crust is a network of magma chambers and conduits, and activity in one part of this network can affect another. For example, the eruption at Mount St. Helens could have caused stress changes in the crust that might impact Yellowstone's magma chamber. Both Mount St. Helens and Yellowstone lie on the North American tectonic plate, and significant geological activity on this plate can have far-reaching effects. While it is not certain that an eruption at Mount St. Helens would trigger an eruption at Yellowstone, scientists take this possibility seriously. They use sophisticated models to predict how changes in the Earth's crust can propagate across vast distances. Following the 1980 eruption, monitoring efforts at Yellowstone intensified. Seismic sensors around the park were recalibrated to detect even minor seismic activity, which could signal volcanic unrest. In addition to seismic monitoring, scientists use GPS technology to track ground deformation, a key indicator of magma movement beneath the surface. Increased ground deformation can suggest that magma is rising and potentially leading to an eruption. New technologies, like interferometric synthetic aperture radar, INSAR, use satellite data to create detailed maps of ground deformation over time. This technology allows scientists to monitor large areas with high precision. Gas sensors are another crucial tool in monitoring volcanic activity. These sensors measure volcanic gases such as sulfur dioxide and carbon dioxide, which can provide early warning signs of volcanic unrest. For example, an increase in sulfur dioxide levels might indicate that magma is approaching the surface. Dr. Rachel Green, a geochemist at YVO, explained that additional gas sensors have been deployed around Yellowstone to better understand its volcanic system. These sensors help scientists detect changes in gas composition, providing valuable clues about underground volcanic activity. Predictive models and simulations are at the core of understanding and preparing for volcanic eruptions. These models use data collected from seismic activity, ground deformation, and gas emissions to predict future volcanic behavior. One commonly used model is the Volcanic Explosivity Index, VEI, which classifies eruptions based on their explosiveness and the amount of material ejected. By analyzing past eruptions, scientists can estimate the potential severity of future events. Recently, more sophisticated computer simulations have been developed to predict volcanic behavior. These simulations take into account complex interactions between magma, gas, and rock within the volcanic system. They can model various scenarios, such as different levels of magma influx or changes in volcanic conduit structures. A recent simulation at Yellowstone examined how a significant influx of magma could affect the volcanic system, suggesting that while an eruption is not imminent, the system remains active and should be closely monitored. Dr. Sarah Williams, a computational volcanologist, emphasized the importance of these models, stating that predictive simulations are invaluable for understanding volcanic systems and preparing for various scenarios. These models and simulations have practical implications, helping authorities develop emergency response plans and guiding decisions on evacuation and resource allocation. By understanding potential eruption scenarios, emergency services can better prepare to protect communities. Before the 1980 eruption, the area around Mount St. Helens was rich in natural resources, with forests, rivers, and fertile lands that supported diverse plant and animal life. The region was an attractive place for human settlement, and archaeologists have found evidence of human activity dating back thousands of years, showing that Native American tribes have long been connected to the land. The eruption dramatically altered the landscape, but it also uncovered archaeological sites that had been hidden for centuries. The blast removed layers of soil and vegetation, revealing artifacts and features that provided new insights into the area's history. Archaeologists have discovered numerous stone tools, such as spear points, scrapers, and knives, made from local materials like basalt and obsidian. These tools suggest that the people who lived in the area engaged in hunting, fishing, and animal hide processing. Excavations have also uncovered evidence of ancient dwellings, including pit houses, which were partially underground structures designed to protect inhabitants from the elements. These sites contain hearths, food storage pits, and other features that provide a glimpse into the daily lives and social organization of past communities. Native American groups lived in the Mount St. Helens area for extended periods and also used it for temporary camps during hunting and gathering expeditions. Archaeologists have found evidence of these temporary homes, along with cooking areas and sites where plants and animals were processed for transport back to more permanent villages. Many Native American groups, such as the Cowlitz, Klickitat, and Yakama, hold Mount St. Helens in high regard, with the mountain playing a significant role in their spiritual beliefs and oral histories. Archaeological findings have shed light on these cultural connections, with artifacts like carved stones and shell jewelry suggesting ceremonial use of the area. One of the most well-known legends associated with Mount St. Helens comes from the Native American tribes of the Pacific Northwest, particularly the Klickitat and Cowlitz tribes. This legend reflects the deep cultural significance of the mountain and its place in the spiritual traditions of the region's indigenous peoples. According to their mythology, Mount St. Helens was once a beautiful maiden named Luwit. The story goes that two brothers, P, also known as Klickitat, and Y East, both fell in love with Luwit. Their fierce battle over her caused great destruction to the land. To stop the chaos, the Great Spirit transformed the three lovers into mountains. P became Mount Adams, Y East became Mount Hood, and Luwit became Mount St. Helens. The Great Spirit placed Luwit between the two brothers to keep them apart. The periodic eruptions of Mount St. Helens are said to be Luwit's way of expressing her continued sorrow and anger over the unresolved love triangle. This legend reflects the deep connection the Native American tribes have with the land and their understanding of natural phenomena. It serves as a powerful reminder of the respect and reverence indigenous cultures have for the natural world. Yellowstone, with its geysers, hot springs, and vast wilderness, has long been a place of mystery and wonder. The Native American tribes that lived in and around the area, such as the Shoshone, Crow, and Blackfeet, have many legends about the geothermal features of Yellowstone. Many tribes believe that Yellowstone was a sacred place inhabited by powerful spirits. The geysers and hot springs were thought to be portals to the spirit world. These features were both revered and feared as they represented the raw power of the earth. One particularly interesting myth involves the Firehole River, known for its warm waters due to geothermal activity. According to legend, the river was created by a giant serpent spirit. This serpent, angered by the intrusion of humans, thrashed its body and caused the earth to open up, creating the hot springs and geysers that heat the river to this day. The iconic Giza Old Faithful also has its share of myths. Some Native American stories describe Old Faithful as a wise and ancient spirit that watches over the land. The regular eruptions of the Giza were seen as the spirit's way of communicating with the people, a sign of its continued guardianship. These myths and legends surrounding Mount St. Helens and Yellowstone have shaped how people perceive these natural wonders. While modern science provides explanations for volcanic activity and geothermal features, the stories passed down through generations offer a different, more spiritual understanding of these powerful natural forces. In addition to Native American legends, there are also interpretations from other cultural and religious texts. Some people see symbolic links between certain parts of the Bible, especially the Book of Revelation, and volcanic eruptions. For example, Revelation 8 verse 8 talks about a great mountain on fire being thrown into the sea, which many see as a metaphor for the end of the world. Even though this isn't a direct description of a volcanic eruption, the imagery of mountains on fire and huge waves suggests a powerful event. Alright, everyone, that's all we have for today. Remember, volcanoes are powerful forces of nature, but with proper monitoring and preparation, we can stay safe. If you enjoyed this breakdown, give the video a thumbs up and let me know in the comments what other volcano topics you'd like to see covered. Don't forget to subscribe for more videos like this.